finding the inverse. Dr. Loeb assigned 1,000,000 questions here, so. Number 11 shows the graph of a function. Copy the graph and draw in the line y equals x. X is this line. And this is x equals. This is then use symmetry with respect to the line to graph the inverse function. And then identify the domain and range of the inverse. Okay, so if we're reflecting f of x across this line y of x, from this point, the graph is going to start right here. And it's going, as it gets, this one gets closer to the positive x, this one is going to, it's got to pass through this point, right? Yeah. And then get closer to the positive y. It's going to look something like this. This is the inverse function. And then it wants us to find the domain and range of the inverse. Okay, so what would be, what input values can we put in here? Including 1? Yep. What are the output values we get?
So on the domain and range, are you just looking at the one the black line
Or black line?
Oh, okay.
Yes, this is
Or you can do that domain and range, correct, the original function.
right.
Can we find the inverse of the function while we're at it? Just kind of cover all bases, like real extra.
Yeah, we can try. I don't know if it'll be pretty. Okay, what do we do here to, if this is y equals 1 over x squared plus 1, how do we find the inverse? Switch the x and y. And then do what? Okay, so we would multiply the denominator. We have to divide by x. Y squared plus 1 is 1 over x. Y squared is 1 over x minus 1. let's see, this was over a certain range in the book, it was, this function was just x greater than or equal to 0, so we would have to maintain that same range. So that's-
I guess the square.
That was the range in the original.
How in the world did you get that to do this math
Look.
stuff? Is that what we're doing right here on the?
No, he just asked me, the instructions in the homework said you don't need to find a formula for the inverse.
Oh, okay.
They just wanted me to find the inverse as some extra practice.
All right.
Okay, other questions from 1-6?
40.
40? You know 40 was not assigned, right?
Okay, you're good then.
39 and 41 are.
Yeah, 39.
Okay. All right, 39 says, has 6 parts, says to express the logarithms in terms of natural log 2 and natural log 3. Okay? Part A is natural log of 0.75. Any ideas? Okay. 0.75 is the same as 3/4. So you can write this as natural log 3/4. How do we gotta get to log 3 and natural log 3 and natural log 2. What do you want to do now? Okay, if we use one of our properties that you have division here, you can rewrite it as natural log of the numerator minus natural log of the denominator. Okay, 4 is the same as 2 squared. We can rewrite that as natural log of 2 to the second power. One more step and I think we're there. Okay, another property says that if we have a square within our natural log, we can move it to the front. We get natural log of 3 minus 2 times natural log of 2. Yes, you need to take this original and figure out how can you write it in terms of natural log 2 and 3. So, and we can do,
Well, do B.
not do B, okay. Which one would you have me do?
F.
F, okay. So natural log of
Square root of 13.5.
square root of 13.5. Okay, any ideas? Okay, do that. over 2?
And then you get rid of the square root, I'll put a negative one in front of the,
-1
just kidding. Yeah, 1/2 in front of it.
to the power. Let's do it to the power so we don't. This will be the natural log of 27 halves to the 1/2 power is the same as the square root. And what can we do with our exponent? Move it out front.
Natural log of 27 minus natural log of 2.
Okay, we can't forget our 1/2, right?
Put it in front. Okay. So, that's what it's trying to say.
Yeah,
It's on both of them.
it's on both of them. So we gotta put parentheses here. Natural log of 27 minus natural log of 2. 27 is 3 to the 3rd power. Okay, move the 3 to the front, 1/2 times 3, natural log of 3 minus natural log of 2.
If, like, the element 2 wasn't in there, would that be 3/2, or would you have to?
Yeah, if this part wasn't here,
Yeah.
this would be 3/2 natural log of 2. Okay, you good on all the other ones? There, 39?
Yeah.
We did 41.
How do you know what's assigned and what's not? Are you saying like what's on the quiz and what's not, or?
No, just the assigned homework.
Or what is that?
Or
Oh,
it's
okay.
got the assignment.
So you've done them all?
Yeah.
Dr. Love, how frequently do you put homework up?
It's been up since the start of the semester.
Holy cow.
Every assignment for the whole year.
They're all up there?
Yeah.
For the whole year?
Alright.
So we want to work ahead.
Good job, Noel.
So I hear 41.
Yeah.
It says use properties of logarithms to simplify the expressions. 41. A. Natural log, sine of theta, minus natural log, the sine of theta over 5. Sometimes we see natural logs and trig functions and we just freak out. Okay, this is nothing more than a simplification problem. And if it said natural log of 3 minus natural log of 3 over 5, we wouldn't freak out so bad, right?
Right.
Okay, so it's the same. It's just with a trig function, okay? So what is our property of natural logs that we want to use here to simplify? We got a subtraction,
So divide.
okay? So we can write this as natural log of sine of theta, all of that over sine of theta divided by 5. Okay? So, for doing fractions, we can rewrite this as this